Acceptance.
Hello? Hello, I believe it's time to start. Welcome to this session. This is my second session today on Devoxx Poland. I'll be talking this time about modern versions of Java. So I hope you'll be sailing with me for the next 50 minutes. Shortly about me, my name apparently has some vowels. My name is Piotr Przybył. I am software gardener and also a trainer from time to time. I work in Atomic Jar, and occasionally I also blog on softwaregarden.dev. Even when I go on holiday, Java is somewhere behind me. What I do professionally most of the time is Java and Linux. Sometimes it's Scala, sometimes it's other operating systems. Let's do a quick check. Who's working with Java primarily? Okay, any non-Java developers in the room? Okay, what do you guys do? Kotlin, Scala, Jython? No JS. Okay, I'm so sorry for you. Sorry. All right, let's keep it going. So we covered who you are. One more question: who's on Java 11? Who's on Java 8? Java 16? Come on, raise your hands. It's easy. I'll show you. It's really freaking easy. Look, you go Java version 16, right? At least at Atomic Jar, we're using Java 16 currently at production, so why shouldn't be you? That's the question, right? Before we actually start, little warning for you, caveat auditoris. Everyone can make a mistake, including myself, so don't trust talking heads, right? Verify on your own. So shortly release dates. So as you see, Java is now released, the major version or feature version, shall I say, every half a year. So we're expecting the next release in the coming weeks on September 14th. So there's always this question. At this time, at the end of August, there's this question, shall I stick to the latest LTS or shall I migrate to Java 16, right? Of course, this shouldn't apply to Java 17, which will be LTS, as we all know. Nevertheless, it depends. I would say if your software runs on it, using the latest Java version, this is the version you should be running in production, basically, right? Unless there is something preventing you, I don't know, your library doesn't support it, you like codependency or something like that. But apart from that, you should be using the latest Java version. Maybe don't use preview features in production, especially on premises. But beside that, you should be all good, right? And I'd like to highlight this. There's this meaning or not of LTS. So I'm going to show you a wall of text, but don't focus on the text. I'd like you to focus on the last sentence. Whether the target release is an LTS or not is, in almost always, completely irrelevant. This is from the tweet published by Monsieur Delabassé, and this is a quote from Mr. Mark Reinhold himself. Because some people were saying that at Oracle or OpenJDK, when it comes to Java 17, they shouldn't be focused on delivering new features, but they should focus on stability, whatever it means. And this message is to convince you that whether a version is an LTS or not doesn't really matter when it comes to technical stuff. The stability is the same as usual, right? So LTS is more or less a business term, right? It's not a technical term. Okay, so there's also one thing I want you to remember, that neither these non-LTL releases or preview features are so-called monkey soft or banana soft, right? Of course, the contract behind preview feature means that the feature can change without warning, right? Can be even withdrawn. But beside that, it's stable, and these all non-NTS releases are also stable and solid and robust and secure and so on and so on. So please do use them. So this is my subjective list of the coolest features in latest Java versions. Your list might be different, and it's perfectly okay. So I value the most, I think, the new garbage collectors we have, ZGC and Shenandoah, which are production ready or production released in Java 15. There are records, which I covered in the previous session, so we will be covering records in this session. There's a pattern matching for instanceof and for switch. We are going to see the first preview of this pattern matching just in a few weeks. Yeah, there's this nice story about illegal access. We'll cover that too. There are sealed classes, which are going to be released with the Java 17, and there are also other changes from Project Valhalla and Project Panama. We see them. For example, we're going to see third preview of features from Project Panama. So it doesn't always mean that we will see two versions of a preview feature. Sometimes we will see more, and I think it's good. And I think it's good because we don't need something rapidly. We rather need something to be well thought, well designed, for the future compatibility and so on, so we don't end up with optional.get. Okay, yeah, there are also these helpful null pointer exceptions, which are quite handy. Okay, so Shenandoah GC and ZGC both are, handling heaps up to 16 terabytes. I don't know if you do have that much RAM, especially not after you're running Slack, right? But nevertheless, they are about short stop-the-world pauses. So they should be as short as possible, and they are compacting concurrently. That's basically the whole magic behind them, right? So they don't do stop-the-world and compacting, but they're compacting apart from stop-the-world. They are a single generation, although that might change. So we're going to see young and old again. They are operating on jitting barriers. So this is how it works, basically, right? Write barriers, read barriers. It's like technical stuff. I'm not sure if it's really that important for us, even especially taking we don't have that much time. And one thing I want you to remember is that they achieve these short pauses by working concurrently, meaning more threads, right? So in general, they will consume more CPU. So if you pay per CPU cycle, by using them, you will get to shorter pauses, but you will have to pay more, okay? That's the trade-off, right? So they are not always better. For example, I would say for batch work, it would be better still to use G1, for example. Okay, so how to use Shenandoah GC? Of course, as for any garbage collector, or every time you run Java, it might be wise to set the maximum heap size, right? And then we go for XX, use Shenandoah GC. And also a little warning, it might not be supported in the version of JDK you're using, so you might need to seek for another vendor or something like this, right? How it works on forwarding pointers. Long story short, if an object is moved on the heap, the header is turned into a forwarding pointer. That's how it works, right? And I really encourage you to read more about Shenandoah GC. There are excellent talks and materials provided, for example, by Alexei Shipiliov. And there's this other, and Shenandoah comes primarily from Red Hat, right? And ZGC comes from Oracle. As you can see, you turn it on the same way or similar way. They don't use forwarding pointers, they use colored pointers, so-called colored pointers. So they use 4 bits out of 64-bit pointer to mark, whether object is being moved or not, whether the face is correct and so on. That's why they don't support 32-bit machines, obviously. And again, more documentation for you to read, and a nice talk from Mr. Erik Österlund. Okay. Oops, seems I don't have an internet. Well, when you're browsing this page and internet works, you will see just me discussing them in more detail, how they operate. Nevertheless, now I would like you to check briefly how they work. So there's a little quasi-benchmark. It's not a proper benchmark, of course, okay, so don't quote me on this. Jarek helped me with this benchmark a bit. So what it does a terrible thing. It generates garbage, right? So this is what we shouldn't be doing, like in real life. It's not about, being echo is not about sorting your garbage, right? So this goes to this bag, this goes to this bag. It's about, not generating garbage. But this, for scientific purposes, this time we are generating garbage, so this program doesn't do anything about else except stressing the garbage collector. And again, I'm not going to run it because it will take the precious minutes from our time. Nevertheless, this is how you can run it. Okay, you can tune the heap size depending on your machine and so on. And I'm also flight recording this. I mean these trials to see later or examine later how the thing performed when we were doing this. So as you can see, I was running it, using G1 because that's the default garbage collector since Java 9, right? Then I used parallel GC. Then, as you can see, I had to use an older version of Java for concurrent mark sweep. We also use ZGC and Shenandoah. So after I run it, I collected the flight recordings, right? And here they are for CMS, parallel old, and the other garbage collectors. And this one was done using Java 11. And also one thing regarding garbage collectors in Java, they receive improvements with every version, right? So it might be you have this source compatibility set to 11 in your Gradle build or Maven build, yet you run your stuff on modern JVM, so you have new fancy and shiny garbage collectors, including G1, which behaves much, much better, especially in some scenarios, for example, using JDK 15, than on Java 11, despite it was also used there, right? So upgrading your Java doesn't mean you have to rewrite your code, use records everywhere, or text blocks, and such stuff. It means you run your stuff using the latest JDK/JVM on production, right? So this is how it works. Okay, so when we run it using CMS, you see the automated results say that there's something, with GC pressure, right? With parallel old as well. With G1, things get a little bit better. With ZGC and Shenandoah, we don't see anything red. Okay, so let's spend a bit more time analyzing things. Right, so where do I have garbage collections? Okay, so you can see the longest pause here for CMS. And it was over 300 milliseconds here. Sorry, I can't make it bigger. I don't know how to make it bigger. So it's over 300 milliseconds. For parallel old, we had almost 300 milliseconds. I mean, this is the longest pause, and of course the others were shorter, and you need to pay attention whether it's like a beginning, like the warm-up or not, right? This all matters. I told you it's not a proper benchmark. Nevertheless, for G1, we have, as you can see, better situation. You can see the nice pattern, right? So it takes more and more. And the longest pause is slightly above 100 milliseconds. And then we go for the GC, which is, drum roll please, just over 1 millisecond. Like 100 milliseconds and 1 millisecond. Like 2 orders of magnitude, right? Let's check Shenandoah. And for this very benchmark, or quasi-benchmark, it was like half of a millisecond. Something smells here. Can you tell the smell? Do you know what it is? I can show you. Money. This is how money smells. So if you have the need of having the shortest possible stop the world pauses related to garbage collecting, you want to switch to ZGC or Shenandoah. Okay? You need to tune them perhaps, although initially they are quite easy to start, right? Just these 2 parameters and so on. But this is what you can get if you, for example, if you cannot afford yourself to have like, let's say, 50 milliseconds pause using G1, right? There's the general promise. I mean, maybe now they are like 1 millisecond or 2 milliseconds. I can't exactly remember. But there was like a year and a half, or when the thing went published in using Java 15, they were like the maximum pause was 2 milliseconds using this Shenandoah or ZGC, right? So this now we can see why. And of course, it used more CPU. I warn you. Yet the pause was relatively short, I would say. Okay. Enough about this. Let's go further. Okay, another JEP. I think this one is quite underestimated when it comes to new Java releases. So it's about encapsulating the internals by the default. And actually, I was talking about this in this very room 2 years ago when I was talking about migrating to Java 11. Now it's a standard feature. It's introduced Java 16, and this is the JEP. You can click it, you can read it, analyze it, and understand, hopefully. That's the ultimate goal, right? So, as you know, Java 9 brought us a thing called modules, one of the outcomes of Java Platform Module System, and so on and so on. And they brought us this dreaded concept of illegal access. Right? Who saw the illegal access occurred warning? Yeah, many hands. The others are still with Java 8, right? Or they have proper code. One of the both. We'll see. Okay. So some people said these are just warnings. Warnings can be ignored. Ignore them, right? And worst thing was that some people took this tinfoil hat from them, put it on their heads, and started ignoring these warnings and follow this advice. Okay. We need to remember that this illegal access permit was promised to be temporary. I'll show you that. I'll show you that. Let's run it because I might cheat in the slides. Let's see how it works in code. So where am I? Oops, I might have closed the wrong window or not. This is it. Yeah, it seems like this. Let's see. Java version. Yeah, it's 11. Okay. So let's go for. Sorry. And encapsulate, yeah, internals. So this is a demo, right? And it's a modified version of what I've shown you like 2 years ago. And only now we are 2 years smarter, so to say. So let me run this, right? Let me run this. Let's go for Java, and it works, right? This is a warning, but it's a warning, just ignore it, right? It says, however, an illegal access operations will be denied in a future release. And now this time for this marketing slogan. The future is now. Now is the future, because let's see what happened with Java 16. Boom! Doesn't work. What the heck? It doesn't work. Because you see an inaccessible object exception, I'll be able to make fields and blah, 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 blah. Why? Because we committed the crime of deep reflection. We, summoned the demons of deep reflection by calling this set accessible true. This is bad code. Bad code. It means you're violating OOP principles and so on, and you know better than the library maintainers what should be accessible or not, and so on and so on and so forth, right? So in this code, instead for actually going, because what we do, we just get the value of in the bytes, right? So maybe instead of this, we should be going for like a string, input.get bytes, yeah. Let's get rid of these because we don't need them now. Let's get rid of these because we don't need them. And as you can see, let's run it again using Java 11, because why not? Oh, sorry, of course, comma. It's not Go, sorry. Yeah, it still has this warning, but it's the other warning because of these seconds here. So maybe let's go for now. Get epoch seconds, yeah, get rid of these two, and we can also get rid of these. Right, let's run this. See, no warnings. And this is what you should have in your code. Or this is what the library providers should give you in their code, right? Because we have no warnings here, right? And we are not violating the OOP, we don't have this set accessible true. But let's say life is not that easy. We have this set accessible true. So what we have to do, we instead need to tune it, right? We have to go for these add opens and so on and so on. We have to go like this. So we cannot bless or say, yeah, I know. I just want to open everything that's in module Java base, in package Java lang, meaning string in this very case, to all unnamed, meaning all I have in my class path, right? So then it is known by JDK that it is not illegal anymore because this legalizes it. Right? This is how it works, okay? And this is also the same way I can run it using Java 16, because I can do two things. I can go for illegal access permit, okay? Works again. Or I can go for, you've seen, using this add opens, and so on and so on. Yeah, let me run it. It runs, again, even without this warning. So if you can't get rid of this set accessible true, right? If you can't redesign your code, then this is what you have to do. You have to go for this add opens and so on and so on and so on and so on, right? So I mean, did that prematurely perhaps. It was like a kind of spoiler. Yeah, this illegal access permit was promised to be temporary. And we've seen that in Java 16, now it's illegal access deny, right? So we switch from the friend option to father-in-law option, right? So we can commit this crime only once, and then your application goes belly up. Yeah. Okay, what to do? I haven't shown you. First, it would be the best to get rid of this set accessible true. If you can't do that, then you need to switch to legal access debug or warn and carefully craft your add opens, right? The list can be that long. Or you can set illegal access permit, which I think is bad, or you can stick with Java 15, like don't switch to Java 16 and keep producing legacy code, because this is what it effectively is, right? So there's a poem, ladies and gents. Roses are red, reflection may hate. You shall not use illegal access permit. Yeah, I wrote this. It's my poem, yeah, from my blog. Okay. Yeah, again, a talk for you, when I was discussing here 2 years ago how to migrate using this with this illegal access deny. So if you want to refresh your memory, please follow the link. When you have the internet. And now we are about to see Java 17, aren't we? And things might change again. And I mean, I don't know if this is an Easter egg, but there is a JEP, 403. We know what 403 means, right? Access denied. And this JEP, I mean, even if it's not an Easter egg, it's a perfect Easter egg, I think, just the number of this JEP. Because this JEP says, let me show you what this JEP says, or what it does. Sorry, not this one. This illegal access permit. Yeah, I told you not to do this. And the reason I told you not to do this was this. And it says, ignoring optional legal access permit, support was removed in 17. So you won't be able to set illegal access permit anymore, or deny, or anything. Because in 16, people tend to miss this little warning here. Illegal access is deprecated and will be removed in a future release. The future is now, right? So now we have no other option but to either refactor your code or craft this add opens. And I really, really hope that some people will really stop using illegal access because it's impossible. And when they type set accessible true, their fingerprints will burn. Yeah. So, pattern matching for instanceof. One of the new features introduced in Java 16. Again, JEP for you. Who knows this code? We all freaking know this code, right? And it's so much ceremony. It's so ceremony. Like, okay, if it's an integer, Mr. Compiler, then please let me in. And then you can't just go for like 2 times object because the compiler says, hey, what's the object? Well, it's an integer, just no, I don't know this. You need to perform the casting again, right? So from Java 16 on, we can go something like this, right? We can use an alias here, right? That's why some people, I believe Dr. Venkat Subramaniam himself, coined the term smart casting. I think this is what it actually is, right? See, it's a smart way of saying an integer. Okay, if it is an integer, please name it from now on as integer. And now we can just go double here. So we get rid of this line. It's not needed anymore. Okay? And yeah, smart casting. And it's even nicer when you take a look at the code like this. See? Thanks to shortcutting and so on. If it's a string, then I can, in the same line, check if this string is not empty. And don't lie to me. I know you have this method in your string utils in your company's code. We all have. Okay, so more about this matching. These variables now, or these aliases, aren't implicitly final, meaning they can be reassigned. Not something I would recommend you, but it's possible. They are only visible in the scope they are declared, meaning after you go after this if, they're not visible, obviously. and the shadow field names if you happen to have a field with exactly the same name. Also something we would expect, right? And we can have more sophisticated examples if you please. For example, we can check if this object is serializable. If it is, then we write it's serializable. Then we can check if it's a string that's at least 3 characters long, or else, of course, we can go if it's a positive integer, or then we can go if it's a long, and this long is like -10 or less, or 10 or above, meaning we have at least 2 digits, right? So this is how it works. Also, quite nice to save you from all of these ifs, a single line with this casting, okay? And there are not only plants anymore, it evolves into pattern matching. We will see that. And this will be very useful with records and deconstructors, right? The constructor is an opposite concept of a constructor, so you pass an object and instead you get like the arguments that you were used to create this object, not for every possible combination, of course, but for example, you can imagine how we can work with records, yeah? So it can be like a syntactic sugar or something like this. Okay, briefly about these preview features. So since Java 12, I believe, we have the concept of preview features used effectively as Java 12. Long story short, it's about using enable preview when you compile your code and when you run your code, and when you compile your code and when you run your code also, the compiler and the runtime need to be of exactly that version. You know, so you can't run preview feature of Java 15 using, for example, Java 14. That's obvious, no forward compatibility. But you can also run it using Java 16. Okay, Java 16 is only able to run preview features of its own, and they have to be compiled by Java 16 compiler. Again, if you need to refresh a refreshment for your brains, here's the presentation. It works online. Yeah, and now we're gonna have pattern matching for switch since Java 17. Okay, it's a first preview feature, JEP 406, so it's not so Eastern eggy, I would say. And one thing I want you to remember, and the same applied to switch expressions, the good or switch stays with us. Nothing changes there, right? So if you have a code that was compiled, or even if you have a source code, the source code and the binary compatibility is going to be maintained. Nothing changes here. Only we can go for a newer syntax. All right, here it is, the syntax for you. So as you can see, there are 2 new things. Basically, now we can also have an explicit check for null, right? So we react when this thing that we are matching or switching on is null. So we can react in a something in a specific way. Then we can not only check the type, but we can also, just as with the pattern matching with instanceof, we can check the value that we just matched. See? So if it's at least 17, I say, hello, this is Java 17, and this, in theory, shouldn't happen, because this is going to work from Java 17 on, right? So this is how it works. And of course there is more like catching like parent classes and so on and so on. Nevertheless, Java 17 still hasn't been released. In theory, it shouldn't change yet. The example of row strings tells us that if it didn't hit the production, it's not delivered yet. Sealed classes. Sealed classes, a concept that emerged as a preview feature in Java 15. And we will have it without any changes regarding to Java 16 in Java 17. And this is how they work. Who knows the concept of sealing classes or sealing types from other languages, like Scala, for example? Okay, there are a few hands raised. Okay, so what this concept is about is just you are, for example, a library maintainer, right? And you don't want people to inherit from your classes or implement your interfaces just as they please, because you know better how to do that. And for example, it breaks your code because you need to cover like extra switches or do like extra instanceof checks and so on and so on. So you know better as a library maintainer, for example, or like core library maintainer in your like company, what the hierarchy should be. Yet you can't make these classes final because, for example, they are, I don't know, entities, right? Or they are, I don't know, they need to be like stopped or something like this, right? So you can't make them final. And you can't make them, for example, private classes or package default because the other package needs to access them. So far, we were missing this mechanism in Java, basically, and now it is ready for us to be used. So it says sealed classes, but it's actually sealed classes and interfaces, right? So we can seal interfaces and classes as well. And when we don't want anyone to implement or extend our classes, we can use this mechanism. And we can't, or we don't want to use final. And we can't go for a less visible modifier. And it is to prevent the bad and unintended code reuse by inheritance. Because, I'd like to remind you, inheritance is not bad. It's just it's used badly, okay? When you need like a code reuse, probably you're gonna go for composition, but when you need like sophisticated tree of types or something like this, like inheritance tree, you need to go for inheritance, at least in Java, okay? And it's nothing bad about this. It's just you can't overuse this mechanism to to have this code reuse. Okay, so a brief example. Let's say we have a class and we want to have this class sealed, and now we can have a list of permitted children. Okay, so we then have to go permit child 1, child 2, and child 3. And child 1 is sealed itself. So the story goes again, so it repeats. Yeah, so it's sealed and it permits its own children. Okay, child 2 is final. And final would be like sealed without any permits, but why would we need that? I mean, the final doesn't change. The final doesn't go away. Final stays as it was so far. Okay, so final means sealed for everyone. Okay, no more extending, no more implementing. And although that would be stupid, yeah, that's why we don't have final interface. And then we can have third option, which is an opt-out. We go for non-sealed, and non-sealed opens this child 3 for everyone again. So everyone again can extend it or implement it, okay? And now, permits can be implicit if all these children are in the same class, in the same Java file as the class, right? So if they are all public classes, it won't work. But if they are, for example, package protected, you can put them in the same Java file, right? And if they are all in the same file, then the list, this permits list, is implicit. That's why it's in square bracket. And things is different whether or not you have modules in your application or not. Who's using modules in Java? A few hands. It's not that bad. Cool. So if you use modules, your children must be in the same module, but can be in any package. If you don't use modules, they need to be in the same package. This is how compiler knows where to seek for the children, basically. In the good old times, we called this an UML diagram. Okay, we had UML. I know now it's not so much popular. Nevertheless, you are the library maintainer, and this is your library, and you have this type. Okay, this library type, and you have this implementation. And this and this and this. And these are permitted, okay? And you want these green arrows to work for your own code. Yet, you want the user code to be able only to go for this. I hope you can see these colors, like this is a blue and this is blue, okay? So you want, for example, the users of your library, you want them to be able to include your library type or your, for example, abstract library type, I don't know, as a parameter, as a return type, as a field type. But you don't want them to implement or extend your type. So that's why these red arrows, this one and this one, that's why they are not permitted. So this is the situation we want to achieve, okay? And now it's possible using Java because we can seal this library type interface and permit only these two subclasses or subinterfaces. And then we have this abstract library type implementation sealed again, and it only permits implementation 1 and implementation 2, these two. And because they are final, okay, we don't need any sealed and permits and so on. And this is also final, that's why, it's sealed for everyone, okay? So that the user can't do something like this, okay? They cannot extend because they are not listed, here, and they cannot implement because they're not listed here in this permits list, okay? Still, they can do something like this. They can have a field of this type, they can have a parameter of this type. They can use them, all right? Let me show you that in code. We should have that in code as well. Main Java, sorry. Where is it? Sealing. Yeah, and I have this library type for you here, because you may not trust me, but you should trust the compiler, right? The compiler is the thing you always play a program with. So as you can see, this doesn't work because you see a warning. Yeah, it's not allowed in the sealed hierarchy, and the same here. So this is how it works, basically. Okay. Yeah. So it's time to. I mean, do you have any questions regard to this sealing so far? If you have any questions, raise your hand or wave because I can hardly see you. But there are three ETs, okay? They're kind of overlapping, but they're not the same, and we need to distinguish them, okay? There is visibility. And in Java, it's like, if like class interface is public, protected, package default, or private. That's visibility, if a class is visible to another class or not, all right? There's another thing, accessibility. Because there might be a public class, and I'm not be allowed to use this class because modules prevent that, okay? So accessibility is something different than visibility. And then there's third thing, extensibility, okay? And this is like final or sealed classes, okay? So like in the times before modules, like up to Java 8, we only had the visibility, and for extensibility, we had the nuke option, okay? And of course, they kind of overlap because you cannot extend like private class, or you cannot extend package default class if you happen to be in a different package, and so on and so on. Like that's why they overlap, but they are not the same. And as you can see, sealed classes is only about extensibility. It's not about visibility or accessibility. Okay, there is some removed stuff in recent Java versions. So concurrent marks got removed in Java 14. Nashorn got removed. But I've heard some people decided to like take care of it, so it should leave as a separate dependency or something like this. Anyone still using Solaris? Did any of you use Solaris back in good old days? Yeah, okay. So I use it too, but now we don't have any more Java for Solaris. Experimental AOT and JIT compilers compiler will get removed in Java 17, and so is the RMI activation. I mean, there's more stuff, but I think these are the most popular or the most used ones. The helpful null pointer exceptions. Who has seen null pointer exception? Okay, that was a stupid question, sorry. Who didn't see null pointer exception? Not a single soul. Okay, yeah. That's why, partially from Java 14 and fully from Java 15, we have these null pointer exceptions having a helpful message, okay? So it was introduced in Java 14, only we had to turn it on, like opt in. In Java 15 onwards, we have to opt out. I mean, if you think you have some sensible data, I don't know, GDPR and stuff, you can disable this. But by default, it's enabled even if you have your code compiled to run with Java 8, for example, okay? So if you happen to have a lot of NPEs in your code, this might be one of the reasons for you to install, for example, Java 16 or 17 and to run it. Why? Do you know this code? Okay, it's a badly designed code, yeah, but you get the feeling. Okay, we pack into A, we pack B, and then C, and so on. And at the end, we have this very nice and precious finito. We want to say it's no more, right? And we pass this code to somebody else. Somebody else is doing something nasty with this code, right? And we receive this thing, and we want to check what they actually, if they said anything there, like replaced something in this Matryoshka design pattern, because we want to firmly send end, right? We want to end this thing. It's just null pointer exception happens. And now, who can tell me this is line 37 in the original code? This is line 37. Who can tell me what is null? Sorry? Yeah, debugger can tell me. Okay, if I see the logs only, what can I do? There were two techniques. We were using two techniques, right? The first technique was to if A equals null, then. If A.B equals null, then. If A.B.C equals, and so on, yeah? You know the story. The other technique was A dot slash slash, B dot slash slash, and so on. Then you had separate lines for every axis, right? That was the other technique. Kind of clever or kind of stupid. And now we have this third technique using Java 15. And it tells us, in this very line, I cannot read field F because this thing, meaning E, is null. Okay? So I can't access this because this is null. Okay, this is what it tells us. It describes the problem the consumer is facing. It doesn't tell us, okay, what caused this thing. It doesn't tell us, like, provide us like a, I don't know, like a pointer to a line or code, like, look, it was this class like 2 seconds ago who set this to null. Okay, it won't tell us this, but at least we know that it was E that was null. So if we have this chain of calls, things get much easier to debug. And actually, there is more. No, sorry. Oh, let me find the other way. Let me find it the other way. Ooh, where do we have it? All right, no, string casting. Oh, it should be in 15. Sorry, a wrong project. Let me open it. Java 15, yeah. And we should have it just here. Helpful line pointer, make the message. Yeah. Yeah. Okay. So this is the example we've just seen. And now you see the code. I mean, I was pretty much explicit here to see what was causing us this headache. But yeah, this had to be enabled in Java 14. As I told you, in Java 15 we can disable it. And let's run this code. And I want you to see the messages it generates. Okay, yeah. So the stack traces are expected here, and you can see all these nice messages. So yeah, we've seen this. Cannot read field F because field E is null. Cannot assign field F because E is null. So as you can see, it changes the intent here. Cannot invoke string length, because the return value of hashmap.get is null. Okay, so see, if we have such a call, it can even be that much descriptive. Or cannot load from object array because int array is null. So here IntelliJ is smart enough to perform static analysis of the code, right? But if it's in like an Asian dependency or something like this, you see, you don't have to recompile your code to have this, okay? And yeah, cannot store to object array because it's null, cannot, another array is null, and it can even get the index, see, of the array, right? And then, here for this null pointer exception, we don't see any message. And why is that? It is because we throw it on our own, right? So for this very thing, it won't give you the message, right? This message specifying what cannot be done because something is null. That's one thing. And the other thing is, and if you still happen to have, I don't know, like GB or something, it doesn't work with remote invocations because this thing is not serialized. So if you happen to serialize your exceptions and send them over the wire, to deserialize it and, for example, and use it, then you won't have this message because message is not serialized and it's computed on demand, okay? So when you want to print the message or stack trace, then it's generated. It's not generated when the exception is created or thrown, right? So this is how it works. Okay, let me go back to slides. Yeah, some stuff got deprecated. I messed the slides a little bit, sorry. So this combination of GC got deprecated. Applet API got deprecated for removal. I mean, pretty late, I'd say. And Security Manager got also deprecated for removal, and this is quite controversial for many. Were you using Security Manager, or are you using it? Is anyone in the room using it? Okay, I see 2 people there. Yeah, okay, and even third person, okay. Okay, so please don't quote me on this, but the general message is this from the OpenJDK/Oracle. We have at time maintaining all the calls to Security Manager and securing it and so on and so on. It's so cross-cutting. It was nice at the time when Java was small, like Java 1.1, or it was needed where people had to run their code in sandbox, meaning applets. Now for servlet-side Java, it's mostly unused. And it's a problem for us because little people use it. There's a little benefit from us, for the universe, and there's a huge maintenance cost. That's why several calls, I mean, the thing will still compile and will run, but it will be just a dummy call, like, for example, always permissive, okay? So you might take, think about it for a second or two. Another thing that's still missing here, and some of you might be, where's the thing and why didn't he talk about Loom at all? Well, Loom is still a subject of the future. We are not going to see it, at least in Java 17. And there's always the same, I mean, there's a constant response when we're going to see Loom, and the answer is in the future. Okay, so nothing changes here. There is a code for you if you like to deep dive on your own into Java 15 or 16 or 17 for you on GitHub. These repositories, there's also for previous versions, and also there are other versions, as you've seen some links, despite not working offline, for me going deeper into various versions of Java. And since we have, I believe, 3 minutes, let me show you one more thing. And we are in Java 15, so let's close it. In Java 16, there has been one more warning from project Valhalla. And I kind of like it because, you know, the story with illegal access and project Jigsaw, we received at the same time both this, like the thing and the warning about the thing, right? And when it comes to project Valhalla, we received these warnings in advance, right, in Java 16. Of course, you shouldn't be doing something like this because it won't work with value classes. You shouldn't be doing something like this because it won't work with value classes, and so on and so on. What is a value class? It's like there's a enumerative list of value classes, right? But it is annotated as JDK internal value based, at least for time being. And there's a whole enumerative list of these classes that are annotated like this. And yeah, let me go back. And this is kind of like this, right? It's just when you go and you compile your code with, let's go for Java C. Yeah, I'm compiling this code. You are also going to see the new warning from compiler, synchronization. And if you don't want to have problems like you do have, perhaps, unfortunately, with illegal access, please pay attention to those, especially as they are difficult to see right now, because when you go for Maven, right, they are not displayed. I mean, it seems that Maven is still not handling this new kind of warning, being synchronization warning, for example. And also what you might want to do is, here, you might want to go for such a warning, right? Let me use this, and then running. Okay, yeah, and this is what we have. And now let me edit this, modify run configuration, program, we need to have VM options. Yeah, here. Let's apply and let's OK and let's run it again. Hopefully it will work. Demo goes, please be nice. Yeah, you see, this is the warning. It also tells you at runtime, because you might not be the one who compiles the code you run, right? it tells you that the synchronization is not okay, and so there's this log, and so on and so on. So these things get now deprecated for removal. You see this red line striking through, hopefully. And all these are not picked only by your IDE, but also the compiler and runtime. Please pay attention to these, because sooner or later, value objects are going to become a thing. All right. Summing up, not only for me, not only for Devoxx Poland, just for every talk you attend, please provide your feedback. And since I see you for the first time in like 1 year and a half, I can even accept the paper form if you haven't. So any form of your feedback would be nice. Thank you very much. Dziękuję bardzo. I think we just run out of the time. So if you have any questions, please find me after this talk. Dziękuję.